we were talking about this model explainability very quickly. So I believe all of you are familiar with that. So I'm going to fast track that. So you must explain. So you must explain what your model is doing, right? So why part, right? So what plus why your model is doing certain things as it is doing, right? So that's what we are trying to explain. So for example, if you say that there's a 82% probability of survival, then how did we come to that conclusion? What features played the most important role, right? What are the things which will make the prediction go higher or lower? What will happen if I change something, right? So what if situation? So this is very important as well, which is what if. So if you say if the income affects this much, then what if my income is not that? Well, something else, right? So how it's going to affect? All of that is there, right? Why is it important? The trust, right? So we remember we spoke about the black box, right? So some of the models like the ensemble models, and even for that matter, your deep learning models, they become what we call as a black box, right? So they're not very easy to understand or transparent or clear in terms of what they're doing, why they're doing. And we also want to do the debugging of the model. So what if there is some sort of bias, right? Bias against a gender, ethnicity, age group, right? Many different biases which exist, right? Wrong behavior, feature behavior. What is a wrong feature behavior, anyone? When you expect a particular relation. So for example, if the income goes higher, the chances of getting a loan should be higher, right? But your model says as the income goes higher, probability for you to get the loan is lower, right? So that doesn't make sense, right? I mean, that intuition doesn't it doesn't gel with the intuition, right? So that's where you can really look into this data leakage also. If there is some sort of things happening in your data being shared, that how your decision is really being done, and people can do the reverse algorithm on that, and they can figure out all of the different things, right? So, and then spurious correlation. Spurious correlation, I think the other day we were looking at that, which is the more number of movies some actor or actress is appearing, the higher the number of people who are dying in the swimming pool, right? And those are all perfect correlations, but they're not necessarily the right thing to really do, right? And then we spoke about the compliance angle as well. Banking, healthcare, government, they're very, very high on the compliance, right? So when you want to be working for a model in these industries, it's better that you have a transparent model. That's where, all this talk has been like, why linear and logistic are still the workhorses for the banking industry, because they're more transparent, right? Or if you don't have a transparent model, so either you have a transparent model or you can explain what your model has done and why it has done. That's the main crux of it, right? And there are two broad types of explainability. One is the global, the other one is a local. Global meaning at a 30,000 feet level, what is happening? What features are more important in your model? What are the criteria that your model uses in making a decision? All of those things are at a very high level. And then we're looking at the local. So for example, you may have an instance where a regulator says, so maybe somebody did a lawsuit on you, right? That, by the way, I was not given this loan, which I thought I deserve. And I checked with the standards that I should be qualifying for this loan. Now you're saying local explainability for that individual. Tell me what really has happened. Not at the overall model level, but for that individual, why this person was rated as a defaulter and not as a good loan candidate, right? So for example, in this case, Titanic data, you must investigate why the passenger A, who is age group 60, male, third class, and fare 7, was only assigned a 12% survival probability. Please explain, right? So this could be a very good question from the regulators that you have to really answer, right? So that's where the local comes in. So we just heard about the global, which is at the overall model level. This is at the overall level. And then we are looking at the local, which is at row level or at an observation level, right? At ops level. a specific observation. So that's what basically you would try to understand, right? There are many different ways you can make your model explainable. One is you go with your intrinsic explainability, right? Which is a model which is naturally interpretable. You don't have to build any other layer on top of that or do some other things on top of that. Those models are by very nature very interpretable. Examples include linear, logistic, decision tree, as we have spoken about, right? Why they are interpretable? Because there is an equation. If somebody says, your model doesn't do this on this group of customer or a particular customer, you can go and say, okay, by the way, this is what my equation is. Let's plug in the numbers. Let's plug in all the data that you have, and then let's see what really happens. So it is really very interpretable, right? So this is while building the model. Then the other approach is post hoc, or explain after you have built the model, but before you take it in the production, that your model is explainable, right? And this is what we will be doing for the complex models. This approach is more common for the complex models, which are not very transparent because of the type of the modeling technique that we have chosen, right? But why do we build the complex models? Any ideas? So if they're not explainable, then why do we build them? Bias. Yeah, because you want to get the performance of the model as well, right? So I can build a simple model, but it may not be a performant model. So I need to up the performance of the model. That's why I have to choose the complexity. If adding complexity brings in the necessary performance, then why not? We'll figure out the explanation part on the model as well, right? So that's the main thought behind that. So some of those models include random forest, XGBoost, neural network, and all of that, right? And there are many different techniques for doing that. I'm not going to talk about all of them, but definitely encourage you to create maybe a Git repo. This is a great idea that all of you can work on, where you can say that I have built the model explainability from the different frameworks, right? So including the SHAP, the LIME, the PDP, the ICE, and different things, right? And you can compare and contrast. It's a great idea for you to showcase what can be done. We're going to talk about the SHAP today, right? Which is one of the most popular technique that we use, right? And we will. Sorry? And ask what is the implementation we have done. So it is not necessary that I work on all the frameworks. It's not necessary. One framework? No, it's not necessary. As long as you leverage one of them and you have good understanding of what your model is doing, I think that's more than enough, right? Yeah, so, and then there are so these are more model agnostic techniques. So for example, SHAP will work whether you are doing a linear regression or logistic or X or Y or Z. It will just work across the board. Then there are model specific techniques like, there is something called as a tree SHAP, which is specific for a tree, or deep learning for neural network, right? Deep SHAP and all of that. So I'll just move on in interest of time. So what is the core idea of the SHAP? And by the way, there is a math behind the SHAP as well. So you can take a look at the formula and how does it really work out. But I'll just talk about the intuition first and the application first, right? So then you can take a look at that. So the idea behind this is following. So you start with a base value. You start with the base value of something. Let's say in Titanic prediction that we'll be looking at in a minute. In Titanic prediction, the survival rate for the overall training data was, let's say, 38%. So you can say even before doing any modeling, I'm giving you a 38% survival rate, right? And then I will add the contribution coming in from each of the factors. So for example, let's say I begin with a 38% survival rate. Then I'll say, oh, by the way, I know that this customer or this passenger is a female. So the extra increment that you get from the survival for being a female in the survival rate may be 0.2. That your probability just goes up by 20%. So now you can say that the survival rate becomes 0.58% or 58%, right? Then you can say, oh, by the way, I also know that this person is traveling in the first class. And if they're traveling in the first class, the survival rate goes up by 10%. So now it is 0.68. So like this, it's basically adding the different things. So you can see the base value, contribution from the sex, contribution from the fair, and other many contributions, and so on and so forth, right? So that's what we have. And SHAP is very good in the global, local, as well as, giving you the feature importance, right? And there are other frameworks like Lime and all of that. This is just touching a very, very high level, so you can go through it. I'll keep going in interest of time. So you can see SHAP really works in most of the cases, like, across the board for whatever we're trying to do. Feature ranking, feature importance, they're similar, yeah. Now let me switch gears. I mean, this is there in your notebook, like the web page that I've shared with you. So I'm gonna run it on my system over here so that it's clear for you. I'm not gonna run it, but I just gonna walk you through what we are doing over here, right? So the very first thing, if you want to install all of these explainability packages, then you can install all of them, SHAP, Lime, EL5 and all of that. But I'm just going to use SHAP for now, and then we'll carry on. Over here, we are doing the usual things, which is the pandas, NumPy, Seaborn, random forest classifier, and we are not doing the dummy coding the other way. We are doing the label encoder, which is another way of doing that. And then we can import where are we importing the SHAP? Yeah, so we are importing the SHAP over here. Then we are importing the Lime, permutation, partial dependence, and all of that. So that you can try later on. And all the packages are imported correctly. Any questions so far? Is it clear?
This comes after that, right? Model explanation.
That's right. So once you've built the model and you have to get your compliance team, your legal team, your other departments to say, yes, we should go live with this model. That's where you have to open up your model and say, this is what my model is doing, and this is why this is doing that, right? Because
Explain the rationale behind your prediction.
that's right, that's right, that's right. So it's not doing any other classification, regression, none of those things. It's just saying, I'm just trying to explain what I am doing and why I'm doing that. That's the main focus behind it, right? So let's carry on then. So then over here, you guys have seen this some number of times by now. And I've kept on purpose the data as simple so that you can understand what it is doing, right? Because you're all familiar with the Titanic data. So we're gonna work with 1, 2, 3, 4, 5, 6, 7 columns, and survived is the label, and rest of them are the features, right? And then we do the missing values, label encoder, which is transforming the sex into the 0 ones, right? So the female will become 0 and male will become 1. Right? And then train test split and all of that. And then model training. So we are fitting a simple random forest. We're not doing hyperparameter optimization. So n estimators is 200. What is n estimators? Right. How many trees? And then random stated 42. So we're not doing any hyperparameter optimization, plain vanilla random forest model. And then I get the accuracy of 79%, right? This is where the SHAP really comes in. So what is the instance that we have fitted over here? It's called model. Right? So this is the instance that we have created. And we have fitted for the model. So training data. Using this model, we are saying SHAP, import SHAP, SHAP.explainer, and model. Right? So you've basically created another instance, which instance talks about the explaining power of the model. So then we are getting this explainer, and then this explainer is being fitted on your test data to really, because it knows the accuracy and everything. And we've basically taken the model prediction power, passed it on to the SHAP package. SHAP is now going to make the prediction on the test, and we know what is the actual on the test and everything. So we'll take a look at that, right? So it comes out as the shape of 179, 6, and 2. Can anyone tell what this shape is if you've done the reading? Yeah. So this is the I think we can write here. So if I look at this, oh, I don't have the output here, so I have to go back here. So this is the number of rows in your test data, the number of features, and then the zeros and ones, right? So those are the numbers that we're looking at. And then you can see basically it prints the different values. So it prints three different arrays for you: values, base values, and then data. Like you remember the SHAP is that you have a base value, then you will, based on the data, you will add certain things, and then you'll get the actual value. So those are the three different arrays, right? So this is the SHAP values that are being printed. So I'll just pass it on. And then what we're doing over here is from the SHAP values, we will only focus on the class one. What is the class one probability, right? We're just basically iterating through this array and looking at the class one. And that's where we will create the very first chart, which is the most common way SHAP is being interpreted, right? Very, very common. You'll see this chart all over the place, whether it's the generative AI or conventional AI, people will keep on talking about this. It's called the bee swarm. Bees, basically bees are swarming. So it looks like bees are swarming something. So that's what basically this really looks like, right? So SHAP dot plots and bees or bee swarm, and then you're pointing those values, and then you're plotting this, right? And let's take a minute to look into this chart and then look at what this chart may be doing and what is the objective behind that, and any interpretation that anyone may have on this one. And I think at this point of time, I can switch over to my other one because I'm not pointing the code. So you can read all of this as well. I'll close this window. So it becomes slightly better for you to read and then for me to annotate as well. It's related to that. So it's basically trying to figure out if I take out this feature, then how much I'm able to explain, add something, remove something, add something, remove something. It basically goes in that process, right? Anyone who would like to explain whatever you've understood? And then we'll go to the next chart. Red is more important. Mm-hmm. So I'll explain then. Yeah. Oh, you want to take a step? Okay. Try to understand. Red is a negative impact. Mm-hmm. Okay. So the first thing we are saying is that colors mean something, right? So colors are important. You have to pay attention to the color. That's correct. That is absolutely correct. So let's begin with the color. Uh, Before even we go to the color, what is each dot over here? Yeah, so that's where you can see the explainability really comes in, because if you looked into the any of the logistic regression decision tree random forest, it was just telling you the feature importance. It was not telling you at the individual observation level how things really look, right? So that's the thing that you're gaining over here in terms of how this really looks at each observation level. So each data point is an observation, right? So I believe we had how many rows here in this data? 170 something, right? So I don't have it in my file over here, but I think huh? Yeah, 179. So I think 179 was the number. So you have 179 observations in this chart, is what basically this is, right? So that's the very first thing. What is the overall purpose? It provides a comprehensive summary of the model behavior across the entire data set, right? So entire data set is the operating word, and the distribution of the feature uh, across this distribution and not just the overall average importance. That's the second thing that you're gaining. So that's this chart. Then vertical axis, what do we have over here?
Features.
These are all the features that you input in your model, right? So these are all your features, and these are the sharp values, which is like the explaining power of each one of them and how things are really changing, right? So color coding we haven't spoken about. So color coding, red means a higher value. Red means higher value of that feature, not across the board. And what does blue? Blue is lower value, right? So let's just take a look at this for a moment. If you look at the sex as a variable, what do you think these guys are? Hmm? Remember the dummy coding will be female and male. So female will be 0, male will be 1. So all these reds are what? Higher values. Higher value meaning they're all males for the gender. And all of these are females. Is this clear? So red means higher value. Red doesn't always mean good or bad. It just means for that variable, whatever is being higher, you'll go more towards the red. Whatever is lower, you'll come more towards the blue. That's the spectrum that you're looking at. I'll come to it in a minute, huh? I'll come to that in a minute. So that's basically the neutral sharp value, right? When we look into the waterfall in a minute, you'll say that I'm starting with a neutral. And if I am a male, I will come on the lower side of that sharp value. So that means my probability of survival will come down. So I'll explain that in the waterfall, that will become more clear. But right now you can imagine that as what are we trying to predict over here? We're trying to predict 1. Remember, we passed on that array, which is dot, dot, 1. So we are saying probability of 1. As the probability, as you go on this side, which is the bluer side, female side, your probability of survival is increasing from the 0 base. As you come towards the male side, your probability, which was defaulted at the 0, or I mean, your starting sharp value of 0, you are becoming less and less likely to survive because of the gender. How about this other guy, passenger class? Who would like to explain this one? No, it's not ticket prices, it's passenger class. Yes. It is, yeah, that's right. So which class will be these? They'll be higher passenger class, right? So second class, third class passengers are all coming on the left side of the line. So if you are second class, third class, your probability of survival will be lower compared to the first class passengers, which are on the right side of the vertical line, right? Similarly, fare is flipped now. If you can see, more reds are coming in over here. If you're spending higher fare, remember red and blue, you cannot get confused. Otherwise, the whole thing will get confusing. Red means higher value. So if you have higher fare, your probability of survival becomes higher. If you're more blue, you're all coming to the left-hand side of the line now because you're paying lower fare. That means you are going in the second class or third class and all of that. And that's where this is coming in. Age. Hmm. Yeah, so like you can see slightly more red tint on the left side, slightly more red tint. So you can see people who are like, age slightly higher, they have a lower odd of survival. More bluish things on the other side, but it's like, very, very tight distribution. I will come to the distribution part as well. And similarly, you can see the SIB, SP and Parch, right? So, hmm, uh-huh. You're combining two of them together. No, this is one factor at a time. Only one factor at a time. This is not a multivariate sort of analysis. It says if I hold everything else constant, what is just the importance of the fare? Everything else being constant, right? So that's how basically this is working out. So I was going to come to this point, which is very important point. So just at the very first glance, you should make out higher spread means more explaining power. So you can see the highest spread is in the gender or the sex, right? Very long distribution. Then the passenger class, then the fare, then the age, and then the parch is like, it's like, right there in the center, right? And don't get worried about these points, like, why something is up, why something is down. So by default, it does a jittering. Does anyone know what is a jittering? Jitter plot. Yeah, so let's say if you have 50 points on top of each other, you will not be able to see the 49 points. You'll be seeing only the top point, right? So they explode that, right? It doesn't really mean like, that those points are really there, but they just create a jitter. So it's like, that's why you can see a swarm of bees sort of thing, right? So it's not like, on a coordinate, this point is there, that point is there, that doesn't really matter. So all the points were vertically on the same axis, like this blue versus this blue over here is exactly the same point. So there's no difference at all in the blue, which is there on the same vertical line. If you are like, I mean, sorry, in the same horizontal space, if you move horizontally left or right, then there is a significance which is coming in. Is that clear? So B swarm plot, very, very important plot, which means, let's see who can summarize what we have learned so far for the module champion. Yeah.
Is we built a model and we need to explain how our model works, how each feature has value, and how does it impact on a prediction. So based on the BSwarm output or chart or plot, whatever, we will be able to explain to business stakeholders as to how one feature is has higher value, or how does it impact your overall prediction. So that is the summary of
Yeah. Okay. Anybody else? Okay. So that's basically the first chart. Yeah. In this case, there is no absolute significance of, like, you can say if I start with a baseline SHAP value of 0, if I go to the right, that's how basically the probability is going to change, right? If I go to the left, this is how the probability is going to dip down. But I'll show you another chart which is going to tell you exactly what you're looking for, right? Yeah. Yes. So, but it is neutralizing for that. So it's giving you the feature level importance, right? Mhm. That will come in the waterfall I'm going to talk about. You'll just see in a minute. Yeah. So just bear with me for now. This is the simpler one. This is something that you guys are already used to, right? So it gives you the global importance of the variable, right? So, and it gives you the feature ranking. So it's not giving you the positive or the negative impact. It is saying just in the overall scheme of things, sex will add or has the like the biggest importance and will add 22% to the probability, or take 22% away from the probability also, depending on which side you fall in. So if you're 0 versus 1, from baseline, the fluctuation is going to be 22% probability change in your survival rate. So if everything else remains the same and you flip 1, then this is how it's going to change, right? Then we have the passenger class fare. This gives you the feature importance, but I think everybody's more curious about this, which is what you'll be looking at as the most important feature, right? I mean, one of the main things that you're looking at. So, and this is coming in from the code point of view. I'll show you where we are doing this. So over here, we are doing a waterfall analysis. People have done waterfall chart earlier. You guys aware what is a waterfall chart? Anybody has an intuition of the waterfall? Waterfall chart in PPT, like you would have done that. Uh-huh. Tell me, like, what is a waterfall chart?
Basic that because of say the next for that matter the external factors like your your forex or for that matter taxes or whatever. That's how you have to predict that.
Yeah, exactly right. So let's say I'm trying to explain, and this is very, very important because this is like, something that the, like, all the AI companies and data-driven companies are being driven by. So let's say you say I started my 2024 with profitability of $100. I'm just making up something, right? My 2024 profitability was $100. In my 2025, the profitability has become $120. I want to know what drove this $20, right? So you'll say, okay, the very first thing that we did, the very first thing that worked for us was you will build on top of this, like this, for example. You'll say the very first thing that worked for us was better pricing to Anupam's point, right? So the pricing gave us a lift of, I'm just making up something, don't go literally in terms of the scale. Pricing gave us a lift of $5, right? So my journey from 100 to 120, $5 of that was driven by the pricing, right? Increase or whatever. I mean, like the profitability increase because of that, right? And then you can say this was because of my marketing, right? Whatever that amount turns out to be. And then you can say this was also because of heavy promotions I ran. So if I add 1 plus 2 plus 3, then I get to this $20 lift. This is the waterfall. Very, very good way of showing the breakup of something from your starting place to your ending place, how you've gone, which is exactly what this chart does, right? Which is the waterfall chart. So in this case, since you have the intuition now, so in this case, we are saying for passenger 0, the probability of the, let me just make sure that I'm doing it right. Yeah, so for passenger 0, the probability of the survival is coming out to be this number, which is 12.5% survival. Who's passenger 0? In that X test, the very first row. And you can do it for any other passenger for that matter. You can change, right? This is the local interpretation. Remember, we spoke about the global and the local interpretation. Local interpretation. This is the local. At the passenger level, you can tell what exactly your model is doing, which is the beautiful thing. Because if you look at the feature importance or the coefficients or the R square or the MSC or the MAE, none of those are capturing at the row level what is happening. This is telling you at the row level what is happening, right? So it says, okay, you gave me the passenger 0, and I know this passenger has the sex of 1. What does it mean? It is a male passenger. This passenger is aged 28. He was traveling third class. He had one parents or child with them, and he had one sibling or spouse with them. And this guy paid a fare of 15 pounds. You gave me this information. Now I'm telling you exactly from the base probability, which is anybody, if I look at the portfolio in my data, the survival rate was 37.6%. At the overall portfolio level, the survival probability was 37.6%. The rest of the people did not survive, right? So, but why I'm claiming that this person is only gonna have a survival probability of 12.5%. That's where the waterfall really begins, right? If you come on this side, that means you are upping the probability. If you're going on this side, that means you are going down in the probability. And let's go factor by factor. So what do you think took the biggest haircut or did the biggest haircut for this person? Gender, because the moment you said this person is a male, is this knock off 16% probability, right? From that overall survival probability. So you take off 16% probability, right? So you only explained so basically this person landed over here, let's say over here somewhere. So this explains the 16% gap. What is this next factor explaining? Age. Because of the age, this person took a hit of 9% probability in survival. And then because of the third factor, which is the passenger class, 7% hit. Because of the pouch, because somebody was there in the ship for him, looking out for him, somebody who cared for him, there was a slightly higher probability of survival. And similarly, because this person was traveling with sibling and spouse also, one sibling and spouse, one parents and children. So that basically impacted favorably. But then again, he paid lower fare. So he got a hit again, a 1% probability hit in terms of that. So this is the beautiful thing about the explainability, which is not there in any of the previous metrics that we have spoken about, right? And you can do it for any of the observations. So for example, I will just do it and I would ask you guys to half this one. You can loop through it. You can loop through it. You can loop through. No point visualizing all the hundreds of rows. So like, because it's a visualization based on, you can write a for loop. So whatever you're doing for one observation. So let's say you want to just grab those values, put that in a like a NumPy array or pandas, right? You can do that. No, no. Yeah. So most of the people will just get stuck on this chart right here. That is the most popular in the SHAP. This is the most popular. Anytime when you're looking at the model performance, you'll see this. Then this is nothing new because all the models give you this information, right? Then the biggest utility comes in from this waterfall chart, which is at each observation level, what is happening. So if I run this quickly, then I can show you. Yeah, I think it should be fairly quick. So I got my B swarm and everything. Those are all global. So right now I made a prediction about the customer 0. Let's say I want to make a prediction about customer 59 or the row 59, which is customer number 60. So you can see this is how, and every customer will have a different waterfall, right? So this customer, again, we're starting with the base probability of 37.6% survival, but this customer ended up with probability of 35% of the survival, right? Because of the gender, they got a huge boost of 29%, right? Because of the passenger class, they took a hit, right? That's how the waterfall is really adding up, right? And then net, this is where you land, right? Let's do one more example. Let's hope something different comes in. Let's say for 100 customers sitting on the 100th row. Um, it looks very identical to what we saw earlier. Manual meaning? Yes, yes, yeah. Yeah, so instead of like looking at this, you can, yeah. So there are ways that you can pass on this information, not for the actual data, but you can say, what if my data is like this? What will be the probability there? That's a good question. Huh? No, it's not. So it's taking a different hit. So male, you're not getting penalized by that much because of the other factors' importance. Not necessary. So I think which observation you're looking at? 50, for example. This was a female traveler. Uh, so in this case, actually, something else is coming out significant for that observation. But let's just take a look at maybe something else. 100, was it 100? 59, the one we were looking at earlier. Yeah, see here, it's not the same. So you get more penalized or more reward for doing a certain behavior. So it's not equal. That's how the model is running and negotiating for all the other factors importance as well. So I'll park it here, guys. So this is with you. This can definitely be there as one of the quiz questions. So for example, I can create a random SHAP, and most likely you can bet it's going to be a question, right? A random SHAP that you will be asked to interpret. What does it really mean, right? Hmm? Viva, yeah. Tomorrow, not tomorrow, the next weekend. You have time to really chew on it. So I'll park it there. I'm doing very bad on time today. So I'll rush on to the very important topic, time series. And for time series, you guys have to step into something different, and I'll give maybe only um, 5 minutes of reading time. Otherwise, I'll start explaining myself, right? So if you go in this conventional ML, you have to click on R-based data science. How many of you know R? What time series?
Yeah, because the timing anyway they can
At least get a read of what is happening.
you can give
Just take a look. Just take a look. Just take a look because it's important that you understand. And within the R, click on the article number 8, which will give you a quick walkthrough of a time series. At least take a look. I mean, you should ideally be doing all of this as a homework. Then come prepared. No, this is R-based data science. Huh. Very few now. R doesn't plug into the production. Very hard to do the plumbing. I mean, if you're doing academic project and research, fine, you can go in.
because
Yes. Because they don't work on the production systems. And for us, the bread and butter is the AI engineering. When you want to take something in front of the customer, for training, it's okay.
ready.
Trading, if it is able to digest the real-time information, you're able to do all of that, you have the connectivity established, then why not? R is quite powerful. I mean, so my journey, like people were talking about their own journey. So my statistical knowledge began in 2000 when I went for my master's degree, right? So I was doing my master's degree in chemical engineering, but I wanted to always work for semiconductor because they offered very good jobs. And semiconductor required one thing, stats and SAS. Anybody knows what is SAS? Statistical analysis software. This is a programming language by itself, right? So they will have proc GLM, proc this, all of those proc. Proc is a short for procedure. And still banks like Wells Fargo, Citigroup are doing things in SAS because it's an enterprise level software that is there, right? Related cousin to the SAS was Spotfire and all of that. So I basically spent good 3, 4, 5 years of my life doing this only. Spotfire now, yeah, I mean it's like good commonality and all of those things. It's from the same company, right? Yes, and then there is another tool called Jump, SAS Jump. I don't know whether you guys have heard about that. So these are like the bread and butter for the banking and financial institutions, right? Where you can do things because it's all heavy security enterprise softwares. There's very little anybody can do to breach them, right? So this is how I started, Santosh, my journey, right? In terms of, and then so I was like, even though I was chemie, I was taking a lot of these courses from computer science and maths and all of those things, right? And I really enjoyed all of that. So then basically I could have gotten like degree in CS also because I've done so many electives from there. But then I was able to get in NTI and then do the things, and it was purely the statistical analysis. So SAS was the the go-to tool for very long period of time. Then it became R. To Arpan's point, all the researchers people in the education industry, they were all like, big supporter of R, then do things in R, right? So initially it took me a while to figure out what is R, because it doesn't really make any sense, right? Why would you just name something R, right? So that's it, right? So like, I mean, there is, that's right. That's right, yeah. And it's really good. It's really good. I mean, that's what I'm saying. I did R for like, many, many years, like, 5 to 10 years minimum. So 5 years you can assume over here, 5 years over here. And at that point of time, slightly Python started to overlap while doing R, right? And then now we are in the situation where it's all Python for the native AI companies. And mark my word over here, native AI companies. Not the legacy education industries, not the legacy banking and financial companies, healthcare, government, and all of that. Native AI companies don't even know what is R or SAS. Like they have the AI first approach. They are doing everything from AI first approach. So let's say you want to do a lending business. You could have been, a Bajaj Finserv, which is, doing lending first, then trying to apply the AI. If I start my own lending business right now, I'll say every decision that I'm going to make in the process will be AI first, right? So that's where you can see all the new gen companies are Python or script also, right? I mean, or Ruby on Rails or, some of the other things. But if you know Python, you're good to go, right? So that's where I mean, even though I have done all this coding, so believe it or not, like, all this, I didn't have the chat GPT. So during that time, so I did all this coding by hand when I created this article in R. But if you ask me to do any of this right now, I will not be, because I've forgotten everything, right? So all of this is in R only. You can see this is a time series modeling in R. So people who are passionate, you can definitely go and do that, but I will not be covering that. Yeah, but it's all there. You can definitely do it and you can figure out what is happening. In fact, R in many ways for time series is a better model because of the, like, some of the components which come in, and you can see we can form the equation as well. I don't have time to really go in that detail in time series today, but it's a module by itself. Like one day just goes in a time series. So we'll just try to, like, give you a high level overview, and then I will assign the homework to you. To Ajit's point, I will not waste time for you guys to tell me. I will tell you what exactly is a time series. Does that make sense? And there will be definitely questions on this in the quiz as well. Meaning Viva and your exam as well. So pay attention. So time series is nothing but when you track a variable over the time period. So what are we plotting over here? At that point of time, Apple's price was $187. Can you believe it? What is Apple's price right now? Share price. 255. Oh, okay. So maybe they have split. So you guys are aware of the split also, right? So sometimes they split, like Amazon's price was, $1,000 something, they split it and then it became 200 something. And then again, it's climbing up there. So it's not really apple to apple. But yeah, anyways, so because Apple has grown multiple fold from there on. So what are we plotting? We are plotting the stock price and we are plotting against the dimension of time. It's a time series. Yes. We are plotting GDP over many, many decades. What is this chart? It's a time series chart. We are plotting Bitcoin for one day only, one day, within one day. What is this? Time series only, right? So what is the moral of the story? Anytime you're plotting any variable or you're measuring any variable over a period of time, that period of time could be seconds, could be minutes, could be weeks, hours, days, decades, centuries, or even higher unit that you can imagine. It's nothing but a time series model, right? Which is different from a linear regression model. Again, a great quiz and Viva question. How is it different from a linear regression model?
series
Huh.
having two variable, it's time variable in X and Y is dependent variable. It can be sales, it can be anything. In linear regression, it's not necessary that our text will be timed.
Yes. So I can probably give you my sense on it. I mean, I know this is not the right area because I'm gonna, that's okay. So in linear regression, you say y is a function of x1, x2, x3, and so on and so forth. Here you will say yt, the value of variable y at time period t, is a function of y t minus 1, y t minus 2, y t minus 3, and so on and so forth. So what has happened previously will play a role in what happens now, is what the time series model is, right? So time series, simple time series, there are time series where you can have this as well as the x come in as well, right? But I'm saying simple time series will be the same variable. So you can imagine it's regressing on the same variable, but the values from the previous time period, right? So that's what the time series model really boils down to. So it can be any minutes. One thing will be common, time series will be a particular variable over a period of time. Why do we do a time series? We want to understand what has happened in the past. And looking into the historical pattern, we can do forecast. And that's again a different term between prediction versus forecast, right? So if you have done your ML correct, you will know that time series is not a prediction, it's a forecast, right? And the longer the forecast, higher the amount of uncertainty. So if you were to forecast how much will be your weight tomorrow, with 99% confidence, you can say plus minus 100 gram, or unless you eat like crazy tonight, right? Right? Or something happens, right? So you can, with 99% confidence, I can say my weight will be 74.1 with plus minus 100 gram with 99% confidence. If I say how much will be your weight from 10 years from now, that band will, like, it could be anywhere between 65 to 85 kg, depending on how I'm doing, right? And all of that. So this time series model also works the same way. Forecast for the near time period will be generally more accurate. Forecast in the future will be less accurate because there's a lot of uncertainty in between that will be coming in, right? There's many different things, like, sales people will do the forecast, how much revenue we can do. E-commerce will do the forecast, like, on that day, how many customers I can expect on my platform, all of those things, right? And stuff like that. So basically very important. And then a lot of you guys have the interest in trading, right? So time series plays a very important role in the trading, technical trading particularly, right? There are many things, like, they will say support and resistance. They will say head and shoulder, cup, right? All of those are nothing but like just time series modeling, the pattern coming out from the time series modeling. So it's, huh? Hedging. Hedging is also there, but hedging is a different thing. I'm just saying, based on time series, there is something called as the Bollinger Bands, for example. So when you're looking at the moving averages, yeah, moving averages is a big one. 200 days moving averages, 50 days moving averages. So they will say 50 days cuts the 200 days moving average. It's a bullish sign. Candlesticks. All of those are nothing but a time series model, right? Very important model. That's why I want to spend some time talking about this. A time series can be broken out into four main components: trend, seasonality, cyclicality, and then random noise.
Trend, secular trend,
Yeah. What is a trend?
it is like overall direction of the business over many years.
Hmm. That's right. Okay.
Population growth
Hmm.
of that.
Hmm.
Seasonality variation is like a pattern which appear, or it is a periodic movement which appears after a fixed time interval. Like every year, Diwali, sweet sales will be high, so that will come every year.
Mm.
So that is
Seasonality.
seasonal
Yeah.
variation. And seasonal index is how by every season works like off or below average. So now cyclic is same wave kind of variation, which happens over across many years. Like we can correlate with business cycle like um, recession, uh, depression, recovery, and that is there. The
Sure.
prosperity,
Sure.
prosperity.
Yeah. Okay.
So that is called cyclic. That is called and that chart. What it will be that is cyclic. Another one is irregular. If we cannot predict, we cannot. That is unexpected things like war, like of situation.
Sure. Sure. That's good. So you can see this is we are plotting the USD INR exchange rate for the last 5 years. So trend is like, when you look at a chart overall, where is the trend? Where is the chart heading as the time passes? So it's heading like this up. So that component is the trend. Let's pick another one. I don't know. Some company which is not doing good. Anybody remembers the chart which is coming down? Huh? Vodafone.
No,
Intel.
now it takes.
Hmm? Infosys also.
During appraisal cycle, every company.
No, I want to show you a long-term trend as well. So yeah, long-term trend. This is a good one actually. What do you think is a long-term trend? It's not going anywhere, right? It's a flat. It goes up, it comes down, it goes up, it comes down. Long-term trend, it's flat, right? So you can see. So if you invested at this point, you're back to the same point right now. I mean, you took a joyride like a roller coaster, and then you came back to the same point. So the long-term trend for Infosys is flat line. Everybody sees this point? So that's a good chart. So that's what basically the trend component is all about. Hmm? NVIDIA? NVIDIA will be like exponential trend. That will be an exponential trend. So like, I mean, even so you can see this is an exponential growth, right? So don't go with the actual values, but you can see this is not a linear line. As the time passes,
Upward.
yeah. And then you had a entry point over here uh, last year April only. Like I think there was a big meltdown, 20%, 30% correction. Then again, it's just going the same. We'll do that later on. Gold will be trending higher as well. So trend is something which is there that you can spot for a long-term line, the direction where it is going. Seasonality, as Erpan was talking about, something which goes up and comes down. Every summer, ice cream sale and Coke sale will be going higher. Every winter, thermal wear sales will be going higher or down, right? That's why you can see those advertisements coming in during that time. Have you seen in the peak of the summer somebody advertising for the thermal wear? No, right? So that will be absolutely absurd, right? Because nobody's going to purchase them during that time unless you're going to a cold area. So that's what the seasonality really means. And seasonality can be any timestamp. Like Bangalore traffic, what is the seasonality? Anytime is a season. Yeah. But I think you can still say it's like a peak hour, sometime in the morning, sometime in let's say Whitefield Road, for example. No? Disagree. Let's look into the visits to the I don't know, hill stations maybe. Visits to the hill stations maybe picking up during, like, summertime, the kids vacation time, then again during the winter time, Christmas time and all of those things. Yeah. Airfares, all of those are seasonality. When something happens at the same time over and over again, it's called the seasonality, right? So you can bet that's going to happen during that time. Chocolate sales will be going higher during the uh, Thanksgiving, Christmas time in the US. Flower sales will be peaking today among all the years, right? So, like, this is what the seasonality really boils down to, that, something that you can predict is going to happen, definitely following a particular frequency. That's seasonality. Random noise, no explainer. It's a random thing. Cyclicality is a tricky one. Cyclicality is basically a cycle which is unpredictable. Like, that recession has hit us, but nobody can say recession is going to be April of 2026. Even if they're predicting, they don't know for sure, right? So cycle is when you get in the cycle and that you are already in the cycle. Like, what is a recession? What is the technical definition, anyone? That's the English definition, statistical definition. Huh? Nope. There is no guarantee for recession. That's what I'm saying. Cycle is not guaranteed. 2 quarters of negative GDP growth. 2 successive quarters of negative GDP growth is what technically, 2 or 3, whatever that number is, but that's what the economists call that as a recession. But you won't know unless those have happened, that you're in a recession, right? It has happened already. Then you say, oh, we are in the recession, boy, right? But you cannot say, okay, we're going to enter into the recession right now. So you are in the cycle. Similarly, stock market also goes through the bear and the bull cycle, right? What is a bear cycle? Where no matter what good news comes in, the stock refuses to go anywhere. You just say, okay, no, I'm going to be sideways or I'm going to go down. Bear cycle is like no matter what, like, company is, everything is just going up like anything, right? So again, you will know that you're in a cycle when you are in that cycle, but you cannot predict that, right? So building on that, I mean, there are many, many other things. I'm not going to go in the detail, but there is like an additive seasonality. There is a multiplicative seasonality. So additive is basically for products which are uh, recession proof or like, other external factors proof, right? So no matter what happens, you will buy that amount of things, right? Multiplicative seasonality, it's also a function of what is the base level. So for example, let's say firecrackers. I don't know whether it's a multiplicative or additive. So every Diwali, people will buy firecrackers worth of 20,000 crores in Bangalore. And no matter how much firecrackers were sold earlier, every Diwali, they will add 20,000 crores higher firecrackers in that time period. That's going to be an additive time series. It's a fixed amount that we're adding. Multiplicative meaning if, like, let's say firecracker trend is going up like this, it's always going to be 20% higher. That's a multiplicative time series that it's being multiplied, right? So that's the multiplicative part. I'll move on. So there is like many, many different techniques in the time series. There's Holt Winters. It's called the box Jenkins also coming, basically people who came out with this. Holt Winters is one of the very popular one. There's also called ARIMA, which is auto-regressive integrated moving averages. And each of these are like, science by itself. Like, Arpan was saying that people are using R. So they are using R for mostly these things, right? I mean, building a very good model. And there's something called Prophet. This came in from Facebook. So they were doing the traffic prediction using Prophet in their company earlier on before they open sourced that. So I will show you all of them, but I'm assuming you will go through and try to understand this because if I explain all of this, it will take me very long time, right? So I'm just gonna give you a code walkthrough so that we can cover the last topic of the day as well, which is the auto ML, right? And that we'll be finishing up. But this is quite detailed and I will not ask any quiz questions on this, like, like these parameters, but it's good for your knowledge if you really want to become a good in time series modeling. There's a lot of people who have done the uh, BA and MTech earlier on, and they built good projects on this, right, in their companies using time series modeling. So you can definitely spend time. There will be questions, but whatever I have spoken so far, right? So, yeah, if you have like, something being measured at equal interval of time, or even some cases random interval of time also, and then you have that metric, it's a time series data. No, no, time series model. Yes, because that's the explanation I was giving over here, that all the previous models we have seen, they do this job. at a given point of time. So you tell me the person who is walking right now, what is the age, what is the income, what is the civil, and then I'll tell you right now, what is their default probability. Time series says, give me how this person has done in the past, and then I'll tell you what the future lies, which is forecasting, not the prediction. Right? You had a question? Any interval of time. Any interval of time.
Say when we look at the sales data will have as per the day, month, quarter, yearly. So that's one data. And I look at the e-commerce data in terms of how many visits, when it happened, what time did it happen, what was the seasonality, whether it happened during the night time or during the daytime, how many people were present. So it's time specific timestamps and
Yes.
then correlation. So we vote for both.
Yes. It could be like you have to build two different time series models, one for one variable, one for another variable, one for one time unit, another one for another time unit, but it's a time series model. Variable should be continuous variable. Yeah, that's correct. It cannot be a categorical variable. That's right. No, no. Okay, so with that background, you cannot predict the recession. That's what I'm trying to say. You can only predict, okay, that's good thing you reminded me. So time series model, I skipped that step. So good thing you stopped me there. So time series model only predicts these two or three components. Random noise also it's not going to predict. So it's going to predict the trend and it's going to predict the seasonality. And one of the biggest assumption in a time series model has been, which is not stated clearly, is that whatever has happened in the past will continue to happen in future. That's the underlying assumption. That's any time series model will assume. Whatever has happened in the past will continue to happen in future, right? That's why it's called the trend and seasonality and stuff like that, right? Now, if there is a catastrophic event, no matter what good model you build, no model is going to sustain. Same thing happens with the time series model. So even though you model, like all the quant companies may have predicted that the stock price will be for NVIDIA $5,000, right? But there is a sudden AI meltdown. All bets are off. So the biggest assumption in a time series model is the history will continue. That's what the underlying model is, right? Which is a big assumption, but it works because we're all victim to a certain way of doing things. If this event happens, everybody's going to jump in and withdraw the money. It's always the fight between the greed and the fear, right? So we all follow the same thing. No matter how educated we become, we follow certain animal instincts always. So that will always be the case. So history will repeat. So if the time series is not working for some period of time, it will come back and start working because of the that very nature. Yeah. So we're only predicting the trend, the seasonality, the random noise, cyclicality, we cannot account for. We cannot predict when the next recession is going to. So those are economists who will predict that, but they will predict based on the macroeconomic situation. They will say, oh, I see that the job growth has stalled, right? I see that the number of vehicles are being sold is less, right? I see the unemployment benefits are creeping up, right? And I know that there is a pressure on dollar, right? I mean, many things. I'm not an economist, right? So they will make a prediction, but that's not a time series model. Yeah. So let's carry on. Yes, yeah. You can combine anything together, like prediction, forecasting, economy, everything together. That's how basically you'll build a solid model, right? So it doesn't have to be a one trick pony that I only do a time series model, or I only do the prediction, right? Or I only do this, right? So you combine all of them together to really create the maximum value, right? No, I'm not saying you cannot use it. I'm saying it's just very hard to predict. No time series model predicts the cycle actually. That's not a cycle though. That's a seasonality. 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 If you know there is a pattern, that pattern is going to be captured in the seasonality. Cyclical is like I explained, like there'll be times when something will suddenly happen, right? You are in that event and then you realize that later on, like a recession, for example, right? So like, suddenly you know that there has been a lot of layoffs and then you are in the recession cycle. Oil prices follow cycle. Oil prices is a very good example. Huh? Exactly. So cycles are longer, they are unpredictable, and you know that you're in that cycle. So for example, metals right now are going through a very big upswing. That's a cycle. Who told you? Anybody told you? Any of your financial advisors told you like 3 years back you buy gold and silver? Nobody, right? And nobody's gonna tell you that tomorrow or 1 year down the road it can crash also. Silver has already crashed from 4 lakh rupees to 2.5 lakh rupees per kg. Imagine the poor guy who bought like 10 lakh rupees of silver at 4 lakh rupees. Now they're suddenly looking at 50% losses. But the same guy can be laughing all the way to the bank when it goes to 8 lakh rupees. But can my time series model predict that? Maybe it can predict it, but it's a function of also a cycle and then looking into the macroeconomic thing on what is really going to happen, right? So it's not pure statistical thing which is going to happen. So we'll use this time and I'm not going to share this code because that's a homework for you. So all of this code is there in these blocks, right? So no. Let me complete. So you have the first model, which is called the, so you'll come back in this mode now in Python based because we have already covered the fundamentals. So there are two models that you have to run. I will not ask you to run the whole winters, but two models I know I have done the documentation on. And those two models are right here. Anybody spots that? Where is the time series hiding? Thank you. So you will have to build this model profit end to end, which is, you can follow along what we're doing and I will explain you all the things. Profit is one model that you're going to build on the same data that I have over here. And then you will be also building an ARIMA model. And I'll explain what the ARIMA model is, which is the next line item, which is article number 46. And Abhi, you can take down the direction. Build the time series model using ARIMA and profit on the flights data per the blog article number, whatever those article numbers are, 45 and something. And that's what their assignment is going to be for submitting today, right? So, but before I go through, maybe let me just use this data very quickly to motivate the discussion as the next step. So this is the flights data, very old historical data, but very, very popular data for the time series modeling. So till now, which data you are familiar with? Titanic, Iris, or housing prices, right? So it's not like that we don't know any data, anything else than Titanic or Iris or housing prices. It takes away all the complexity of understanding the data nuances to the specifics of the modeling and how each model, how each technique really works, right? So that was the rationale. Similarly, this is the holy grail of a time series modeling, which is called the flights data, right? So what this data has, this is also coming in from the seaborne, right? What this data has is the number of passengers who are flying in the given year, given month, and I think it's going from 1949 till 1960, right? So you can see this is 144 observations. So how many years of data we have? Somebody help me. 144 months, how many years? 12 years, right? Each year has 12 months, so 12 years of data that we are having. And these are the number of passengers who took the commercial flight. Not 112, this is 112,000 passengers, right? Let's say this is in the US. I don't know which country this data is coming in from. So all of that is there. And then we are doing a bunch of different things. I'm not going to walk you through step by step. I'm assuming you'll be able to figure it out. And I have a working code in case if you are stuck on a particular point. So then we plot this data using the seaborne heat map. Anything who would like anything that you would like to highlight on this chart? What are you noticing? Hmm. Yeah. So when you began your journey, there was not much like a seasonality. It was like, people who needed to fly were flying in 1949. But as the year progresses, more and more number of people are flying. So what will be the trend in this data? This will be an upward trend. More and more number of people are flying. And not only that, there is a heavy amount of seasonality also coming in. Every June till August, September time period, the flights are picking up, right? Or the people who are flying are going higher, and that corresponds to the summer months in the US, right? So the kids' schools are off. Weather is much more suitable, not so much cold and all of that. Much nice weather. So more and more number of people are flying for fun trips and all of that. So you can see the amount of seasonality is also getting bigger and bigger. Why I'm concluding that? Because no seasonality over here. Everything is yellow. As you're going on year over year, it's like heavy peaks are coming in and heavy troughs are coming in. Heavy peaks, heavy troughs. So it's going up and going down very, very fast over a period of time. And then you can see over here, it's like dark seasonality, which is also being captured over here in my data. And again, I'm not giving you walkthrough of line by line, but I'm just talking about this one, right? So why I'm saying seasonality is getting bigger and bigger, anyone? Yes.
Within a year.
Yeah, so you're looking at this. So there is a trend. Everybody agrees there is a trend, a line which is going through like this. But then these peaks and troughs, they're like getting bigger and bigger, right? So there's a huge traffic suddenly building up, and then it drops like anything also, right? So it drops below the baseline as well. So that's where this is a typical sign of a multiplicative seasonality. If the peaks and troughs were even, like every time it's going to be 20,000 passengers more, those will be additive seasonality. This is a multiplicative seasonality. Don't worry if you don't get it right now, but you can understand that later on. And then what we can do, this is like the best friend that you have in a time series model. You can decompose the time series. Decompose the time series meaning you can break the time series into its constituents. What are the constituents we spoke about? Trend, seasonality, and residual, right? So let's say your business was not even aware that there is any seasonality, like your case, Poonam. Let's say you have some metric that you're tracking and you're not even aware of the seasonality. The moment you break your time series, you'll say, I see that every 7 o'clock something is happening, right? Or every 5 in the morning, there is something happening, right? And there's a great insight by itself without even doing any forecasting, just doing a simple statistical decomposition of the time series. And that's what it looks like. So I have just done the decomposition. This is my original time series. I broke the time series into the trend. So this is a trend and this is the seasonality, right? So, and then we'll be looking at that a little bit later on. And then this is a random noise. Random noise meaning that we cannot really make a prediction, right? So that is going to be the amount of randomness that you're going to have. So I'll let you guys play with this later on. Yeah, so then what we're going to do is, are we doing this one, Arima? Yeah, we are doing the Arima first, yeah. So Arima is basically a short for, or why don't we do this, take a break, come back by 3:45, and then I'll just give you the walkthrough very quickly. And then we'll pick up the last topic, which is the auto glue on. And then we'll discuss that. Yeah. Thank you.